We're going to talk about Project Loom and then all the features of Project Loom, like virtual thread, structured concurrency, scoped values. And you might ask, what are things that we can do with it to write easily readable concurrent code? This looks like a very simple thing, and that unlearning is a difficult part. That is a problem.
Welcome to IntelliJ Idea Tech Talks, where we talk about technology, tools, frameworks, and other interesting things. With me today is my friend Bala, or Balkrishna Rawool from ING. And you do great talks on various Java topics, I have to say. And today we're going to talk about structured concurrency, virtual threads, and scoped values.
Well, thanks, first of all, for inviting me and also for the great introduction.
You're welcome.
Thanks a lot. Yeah, okay, we're going to talk about Project Loom and then all the features of Project Loom, like virtual threads, structured concurrency, scoped values. More importantly, we'll see them how we can use these things together and how they nicely fit together, how the APIs work together to allow us to write easily readable concurrent code.
Right. Because currently we have more of unstructured concurrency when using the current concurrency features in Java.
Yes. And concurrency is also a very hard bit to get it right. And as much as support that is available in the language itself really helps. And let's see, let's evaluate some of the features and see
how people could use them.
Yes, exactly.
Cool.
Yeah, let's start with the first thing, Project Loom.
Yes.
It is one of the important projects at OpenJDK, and what it does, actually the purpose of this project is to provide high throughput, lightweight concurrency, and it is also easy to use.
Yep, it's the easy to use for me, yes.
Exactly. You have experimented with it and you have seen some things as well, right?
Yeah.
So there are three main features, virtual threads, structured concurrency, and scoped values. We will see them one by one. Also, the idea here is we will create a small Spring Boot application, and we will add these features to that application, and then we see very close to, let's say, real world application. Of course, we can't build real world application in
NDAs and such,
45 minutes, 1 hour, but we will get something which is closer to that, and then hopefully we get a good idea about how we can use these features in our day-to-day work.
Right.
Okay, so let's start with the first feature, which is virtual threads.
Yes.
I usually use this picture to explain how they work or how they relate with the OG threads called platform threads.
Yes.
So what we have in this picture is we have an instance of JVM, which is running on an instance of an operating system.
Right.
Now, JVM generally relies a lot on threads to do things. So we have some platform threads here, and there are also a bunch of virtual threads. And OS, of course, uses its own OS threads or kernel threads. Now, if you look at platform threads are actually a thin wrapper over operating system threads. Now, what does that mean is when JVM wants to create a new thread, it requests OS to create this OS thread. And only when that OS thread can be created, it creates the platform thread.
Right.
That also makes them very expensive. So what that means is when JVM creates a new platform thread, it also requests OS to create OS thread, and therefore the mapping between platform thread and OS thread is one-to-one. There's one-to-one mapping between platform thread and OS thread. And because they are expensive to create, you don't want to create them too often. So when you're done with a platform thread, you don't throw it away. Because creating another one is very expensive, you try to reuse them.
Exactly. So we use pools.
Exactly. We put them in thread pools, and then we use them from that thread pool.
Exactly.
Now, the thing with virtual threads is that they are lightweight. Lightweight meaning they require significantly less memory. And because of that, you can create them in thousands or even millions of virtual threads, which was not possible with platform threads.
Exactly.
And that is what makes them highly scalable.
Right.
There is one more thing that makes them highly scalable. We will see that, we'll discuss that in a couple of minutes. But with virtual threads, the thing is they don't need pooling.
Right. Because they are lightweight, you don't have to save them. You can throw them away when you're done.
Yes, exactly. You throw them away when you're done. You don't put them in a pool. So next time when you need it, you create a new virtual thread because they are cheap. You just create them whenever you need them. In fact, pooling virtual threads. So if you are used to your patterns of thread pools and you want to also use those same pattern with virtual threads, don't do that.
Yep.
It is an anti-pattern. So I think one of the things with virtual threads is that you have to let go of some of your usual patterns of using threads That is the hard bit.
We're getting new idioms, but
exactly.
Also, as we'll see, some of the new idioms I rather like because they're easier to understand.
Yes.
More specifically for the structured concurrency.
Yeah. So some of the things which are fundamental to concurrency or fundamental to readability, we have to preserve those, we have to retain those. But some things which were introduced just to overcome the limitations of threading, those things we should let go. And that unlearning is a difficult part with virtual threads. So one of those things is pooling. Don't pool your virtual threads. But so what happens is that when you have a gem instance running, you have some platform threads, but you have a lot of virtual threads. And virtual thread on its own cannot execute anything. It requires platform thread to execute something. And therefore, they always get mounted onto a platform thread and unmounted. And for that mounting and mounting, we have a virtual thread scheduler. This is newly introduced feature along with virtual threads. And what the scheduler does is it mounts a virtual thread onto a platform thread when a virtual thread requires platform thread, and it unmounts it when a virtual thread does not require platform thread.
When it's waiting for I/O. Mainly so that the platform thread can carry a different virtual thread and do the work.
Exactly. So when, let's say, a virtual thread is executing something and it encounters a statement where it has to wait for a network resource or a database, then in that scenario, it gets unmounted from the platform thread. And then the platform thread is free to use some other virtual thread. And then in that whole process, you don't waste CPU.
Exactly. And I've heard metaphors like, having a waiter in a restaurant that waits on multiple tables, or, not having the taxi wait for you, but rather...
That's the... I heard that first time from Piotr, and I was like, okay, this is a prompt metaphor.
That's a good metaphor, yeah.
Yes. So like for platform threads, you would consider them as, I think he mentioned trains, so you have to wait for them, and then you...
I think he used like the getaway car that had to... wait here, and while it's waiting there, it cannot do anything else.
Okay. And for virtual threads, it's like taxis. You call them when you need them, you have them instantly, and then you just get from one place to the other, more efficient than other.
But the downside is you don't have one waiting for you, so you might have to wait for the platform thread to become available for the virtual thread to continue.
Yes. So we have a limited number of platform threads, which then carry these virtual threads, and you call them carrier threads. Yeah. So in a typical application, you do a lot of waiting. So your threads are waiting for a lot of things. You can imagine microservice architecture where a lot of services are calling other services and then they're waiting for response. Use virtual threads, and therefore you avoid that waiting of the platform threads, waiting of the CPU. So you don't waste your CPUs. The idea is to use CPU to its utmost potential, and that is what makes virtual threads highly scalable.
Yep.
So we'll see some examples. So I'm gonna on with a simple Spring Boot application.
Yep.
And here we're going to introduce virtual threads.
Yep.
Do you have any remark to make? You are smiling.
No, I'm good. Okay. I know where we're going.
Okay. You have seen this.
So because you're working for a bank, we're going to build a banking app, right?
Yeah. So I work for a bank, so I'm gonna use some similar application here. Because it is easier for me to think about that domain.
Yep, I go with web shops, having worked at a web shop before.
So what we'll do is we'll create a simple Spring Boot application, more specifically Spring Boot 4.0. That is the latest version of Spring Boot. And then we'll JDK 26. That's also the latest available. It could use 27, which is in early access.
We could try it out,
Yeah, but for this demo, we'll use JDK 26. And the domain is going to be banking, because again, it's close to me. And I'm really good with names, so I'm going to call my application a bank.
Yes, because there are two hard problems in computer science: naming things, cache invalidation, and
off-by-one errors.
Thank you.
Okay.
I always have to make this joke. I'm sorry.
Okay, let's move to IntelliJ.
Yes.
And see if we can create that application. So what I have here is a Maven project called Spring Boot Loom, and it has two modules. A bank and services. So services is the one that provides a bunch of services that we will use in the a bank application.
Right.
Okay. For the first demo, I have nothing banking related, so I'm just gonna move over to the controller, and I have this hello controller already prepared. So what it does is it just has this endpoint called hello, and it just says hello back to whatever requests anything from it.
Right.
It also prints the current thread. So it says hello back and says
from which thread
it is saying hello
Yep.
from. Yes. So what I'll do is I will start this application, a bank application, and then I will send a hello request to it. I think the font is pretty big, so we might have to scroll a bit to see what is actually happening. But let me quickly send a request to my application, HTTP localhost, and I assume it is running on 8082. And let's send a hello to it. Let's see if we get hello back.
Praying to the network gods.
Yes, and we do get hello back. But
from a thread.
It says thread. So it is actually using platform threads. So we get a hello back from a thread.
So we're not using virtual threads just yet.
Exactly.
Okay.
So we'll switch to virtual threads. I'm going to open application properties. With Spring Boot, it's actually quite easy to switch. So I can simply write spring.threads.virtual.
It's already there.
Enable. Oh.
I saw it in a completion.
Yeah, it was coming because I'm using now ultimate features virtual. I think this is exactly. I should have used the auto completion. Then I can avoid the mistyping. Exactly. Yes. Okay, so now that we have enabled it, let me just start the application and then quickly go to console and send the same request again. And now we get hello from a virtual thread.
So it's that easy to activate virtual threads in Spring Boot.
Exactly.
As long as you're using version 20 or Java 21 and up.
Yes.
Because that's when virtual threads were introduced.
Yes, exactly. So as long as you are using JDK 21 or higher, you can use virtual threads. If you're using Spring Boot with this property, I can imagine for other frameworks, it would be also equally easy to switch from platform threads to virtual threads. So now our application is using virtual thread executor. So every time you send a request, it creates a new virtual thread, and that virtual thread serves our request. So in this case, this Tomcat handler 0 is a virtual thread.
Cool.
So this looks like a very simple thing, but it actually empowers our application to use virtual threads. And you might ask, what are things that we can do with it?
Yep.
Well, one of the main things that we can do is use structured concurrency.
Yay.
And that is what we'll discuss in this part of our conversation.
Yes.
So let me head over back to our presentation and talk about structured concurrency a little bit.
Yep.
So we switched our application to use virtual threads. And now I'm saying that we can use structured concurrency. But how is it possible? How is virtual threads, how are virtual threads enabling structured concurrency? Well, the thing with platform threads is that we cannot create too many of them. So what we do is we create a few platform threads in any application, and we use them very efficiently. In fact, we view a platform thread as an abstraction of a process. And if you have multiple tasks, we submit those tasks to that single platform thread. But the limitation of limited threads is not there with virtual threads. We can create as many as we want. And therefore, we can even create a virtual thread for every task. So if you have multiple tasks,
right,
you can create a thread for every task, and you can let that thread execute that task.
We can fork the thread,
as many threads
the
as we want,
and have them run their own threads and come back when they're done. Yeah.
Exactly. So and then what we can do is we can structure these tasks in the most logical way, the way we want our application to be to behave.
That's one of the things I really like about it, is that the code expresses the structure of the code and how the tasks are being resolved, etc. As we will see in the demo.
In the demo and the remaining part of this conversation. So, as you rightly mentioned, that the structure of our logic becomes visible in the code, and therefore it's called structured concurrency.
Yep.
That's why it's structured. And in fact, yes, I do like it.
But this is currently still a preview feature in Java 26, and also it will be still in preview in Java 27 with some small changes.
Yeah, that is true. It has been preview for few Java versions, so this is I think 6th preview, and that's 27th will be 7th preview. Yeah. Yep. So it has been in preview for quite some time, and they are getting more feedback. The OpenJDK team is getting more feedback from the community so that they can make it final.
Yes, so do try that out at home and let them know how it works for you. or if you have any feedback, now is your time to tell them if it should be different.
Yes.
Or what you're missing or whatever.
Yeah. There have been some fundamental changes in the API.
Yep.
So they recently introduced API called joiner, but in 27 it's also an incremental change. So
small changes on the joiner. I think the third argument is you can now specify the exception that it will throw.
Yeah. And one of the methods is renamed as well.
Small change. So the changes at this point are relatively minor.
Yes.
Hopefully they will remain relatively minor for the next previews.
And if there is more feedback about the ways it can be improved, they can change as well. That's the thing about preview features. So that is where we are in terms of the API of structured concurrency. So let's see how we can use it
in our application. Yes.
So I have a few examples here. So I'm a visual person, so I want to put some things visually.
I really like these.
Thank you. So what we have here is first example where you have a main task which creates 3 subtasks, and when all the tasks are finished, you continue with your main task. Another example where again you have 3 subtasks, but you don't wait for all of them to be finished. As soon as one task finishes, you continue with your main task, and it could be more complicated examples. So where you have your subtask and exactly, and then join few of the tasks and then continue. When those are finished, you create more subtasks, and when everything is finished, you continue with the main task. So concurrency requirements can be very complicated. If you can put them, plot them in a structure, you can use structured concurrency
I like having these graphs, like this is how the task should work, and then you can actually express that in the code. And with the different joiner methods, you can say like either wait for all of them or, as long as one of them finishes and then continue. And that actually expresses in the code the same logic that you have.
Exactly. And that's the beauty of structured concurrency. With Java, we can now use structured task scope API to implement these concurrency examples. Now, the idea with structured concurrency is that, the principle is that when flow of execution splits into multiple concurrent flows, that they rejoin in the same code block. So you basically have the same scope, and then you fork your task, you join them in that same scope. For example, if you implement this example with 1 main task and 3 subtasks, again, them joining and continuing, you will see that the entire forking and joining is happening in the same code block.
Right. And for anyone who wants to try it, if you have code where you're sending off different tasks and then waiting for their results to combine them, that would be a good example of trying out structured concurrency and see how that works for you.
Yes, exactly. And this brings in a lot of benefits. First benefit is short circuiting. So here in this case, you have 3 subtasks, you wait for all of them. What if one fails, if there is an error in one of them? Then there is no point to continue with the other 2. So those
if you need the results from all of them, exactly.
Yeah,
Sometimes you need, if you're hitting different caches and you're fine with hitting just one, then you can specify in your joiner that you're okay with hitting just one.
Exactly. So if you are only interested in one of the successful responses, then you don't care about one failing.
Exactly. But then you can cancel them as soon as one of them returns. So
exactly.
And it will do that for you actually, rather than you having to make sure that you're canceling all your...
Right. So if your logic is like you have main task and you have multiple subtasks and you want all the results, and one fails, the others are immediately cancelled. If you have a logic where you have main task and you have multiple subtasks and you're interested in only one of them being successful, the moment it is successful, you want others to be cancelled.
Exactly.
So that is short circuiting, and then we get that benefit if we use structured concurrency API. Cancellation propagation. So if you have a main task and that is creating subtasks, but if the main task is cancelled, that cancellation gets propagated to the child task, and those child tasks are cancelled as well. So that is cancellation propagation. Clarity, as you rightly mentioned, we see the structure also in the code. It reflects the requirements that we want our
fan.
Exactly. So it brings in a lot of clarity, brings in a lot of readability. And I know you are a big fan of reading code. So so that is one of the big benefits of structured concurrency. That's also why I like structured concurrency. Another thing, this is an extra benefit that we get with structured concurrency API. So it adds an observability part as well. So normally you have your main task, which creates subtasks. And those subtasks can have their own subtasks. You could have, hierarchy of tasks. And because we are creating a virtual thread for every task, we have a big hierarchy of virtual threads.
Yes.
And at any point in time, you want to get a thread dump of your application. That thread dump can reflect that hierarchy. So we see, let's say, a virtual thread, its own child threads, and then child threads of those virtual threads. So we can see a big hierarchy of threads that makes it easy to get a view of the application and also helps with debugging or troubleshooting, finding issues.
As we'll see.
Yes, we will see that in one of the demos. So
cool.
That's the observability benefit of structured concurrency API. Now that you have discussed so much about it, let's see how that works in action. So I'm going to implement something by using structured concurrency API. It's a loan application. So because we're talking about a bank, let's say a loan application. So what happens here is customer applies for a loan, and the first thing that we do is we get the customer details.
Yes.
Right? And using those customer details, then we get their accounts, their loans, their credit score. And the credit score, we have two services that provide credit score. And for us, one of them is enough as long as we have successful credit score from one of the services. Then we use that along with other information to create an offer for the customer. So we aggregate all the information, send it to offer calculation service. We get an offer for the customer and we send that offer back. Now, this is what we're going to implement. Now, if I want to put this in a task structure, it looks like this. So you have a get customer details task, which creates then 3 subtasks, account, loan, and credit scores. And when all those tasks are finished, we have, let's say, an offer calculation, which is triggered, and we get the offer for the customer.
Yep.
And credit score is, again, not a single task, but it has 2 subtasks.
Yep.
And we are interested in successful response from only one of them.
Yes.
Okay, now let's go ahead and implement this in IntelliJ. I will head over there. Let me also, before we go on, let me quickly show you what is inside the services app.
Yep.
So here we have...
And we will share the code afterwards, right? You're okay
yes,
with
we'll share a link to the source code.
In the description?
In the description, yeah. And just play around with it,
try
see
stuff
how
out.
the code is, try those things. If you find something, we'll also share our social handles so people can connect with us, and then if there are any questions, they can ask. So what happens here in services app is we have a customer controller. As you can see, it exposes a bunch of endpoints to get customer details, credit scores, accounts, loans, and offer. So those are available to us.
Yep.
And then we use them in a bank application to get all these things. We create tasks corresponding to
right.
these.
In the real world, this might be multiple microservices, but
Exactly.
for the demo purposes,
we combine them into one demo app, but these are spread over multiple apps. Okay, so let me also start the services application. All right, so while it is running, let's go to a bank application and create a new controller. So in this case, we have a controller called a loan controller, and I'm going to hide the project part. And this is going to be a REST controller, and it has a method which returns an offer called apply for loan, and it takes loan application request as input, and it is available to us as a post endpoint called loan application, and the input is request body. Okay, now you might ask, where are these offer and loan applications coming from? So let me quickly show the project structure so it is clear. So we have a interface called model, and I have put all the DTOs.
You've already put them to save a little bit of typing during this demo.
Save some typing.
You came prepared.
Exactly.
Good.
Preparation helps. So I thought let's prepare a little bit. So
we can't all be as fast as Josh and create a whole Spring Boot application in 45 minutes.
Yeah, that's God mode on with your live coding. It's hardly reachable by anybody else.
Yes.
So we have a bunch of records here, which are the data transfer objects, and I put them in this interface called model because it represents data model. And I've also created a generic exception called a bank exception, which can handle all kinds of exceptions or errors. So we are using loan application request and offer right now, but we'll also use the other ones as we go on. Now, what I have in my loan controller is something that takes loan application request and gives me an offer. And if you go back to the task structure, the first thing that we do is we get customer details. For that, I'm going to create a customer service. I will actually have it already created. So I have a bunch of services already prepared. So I have customer service. And what this customer service does is it has a logger. It also has a REST client. Let's quickly check where is this REST client coming from. It's coming from a bank application where I have this been defined. which is basically a REST client connecting to our services app.
Right.
What else do we have here? In customer service, we have this get customer method, which uses the REST client to get the details of the customer, and that's it. So let's use this customer service in our loan controller. And because I'm using IntelliJ Ultimate, I can simply type customer service and it does everything for me. So it adds this field and it adds the constructor injection as well. So customer service, and then I can do get customer and I pass customer ID, and let me put this in a variable called current customer. So there's something interesting happening here. So I have this method called get customer. This is actually a blocking call because it goes over the network to the services
We have
app.
to wait for the service to give a response.
Exactly. So it has to wait. Normally, when you have such calls, what you do is you have some ceremony around it. You either use future or completable future, and then you have a callback which gives you that response, and then you process that response in that callback.
Yep.
And we don't need to do all of that because we are using virtual threads.
Yay.
So that is another benefit of using virtual threads. Again, adds to the readability.
Yes.
Otherwise, you would have.
Otherwise, we have a bunch of boilerplate around it.
Yeah, and callback,
Yep.
which is an entry to the callback hell. You don't want that.
Yep.
So we can avoid all of that. We can also think of our blocking calls as if they are non-blocking, and we can simply just call them and get the response, put it in another object, use it. So it makes our code more imperative, which adds to the readability. Okay, so we have our customer details. The next thing is to get account details and loan details. Let's ignore the credit score part for a bit. Let's get the accounts and loans details. Again, for that, I have prepared services. So let me quickly show them. I have account service, which is very similar to the customer service. It has a logger REST client, and it has get accounts info method, which uses the REST client to get the accounts of the customer.
Yep.
And then I have loan service.
Which would get all of the customers' loans.
Loans, exactly.
Similar.
Yeah. So we have logger REST client, same as other services.
Yep.
And it gets the loans details. It also has another method, which is called calculate offer, which again gets the offer details. We're not going to use that right now. We'll use it in a few minutes. But let me add those dependencies in loan controller and get towards its completion. So what we're going to do, as we see here, we're going to get accounts and loans details. So first, let me use account service. Again, I use it and it adds the dependency. Get accounts info for the current customer, and I'm going to use loan service and get loans details for the current customer. Now, we have made those two calls. Again, those are blocking calls, but we are using virtual threads, so no need to worry about that blocking. But we want those calls to be made concurrently.
Yes.
At the same time, but that is not what is happening right now. So we want them
now they would be sequential.
Exactly, one after the other. But we want them at the same time. We want them to be done concurrently, so we'll use structured concurrency.
Yay.
I like the little celebration moments
Yes.
of you. So what we will do is we'll use a live template called STS,
Yes.
which adds structured concurrency, the structured task scope API. And this is the pattern that is often used or almost always used when we are using structured task scope or structured concurrency API.
Yep.
The first thing that you do is you call this method open, which gives us an instance of scope.
Yes.
And scope is auto-closable. That's why we use it with try with resources. So it takes care of calling close method and removing some resources if there are any when use of the scope is done. And then we can put our tasks back here, but we want to make them concurrent. So we have this API called scope.fork that is used to then fork these subtasks. So with this scope.fork, we are actually
that means we're now forking them and sending both of them off at the same time rather than sequentially.
Yeah. So that is exactly what we want here to happen.
Exactly.
What it also does is it creates a new virtual thread for every task, and then it does handling of the task in that virtual thread. The scope.fork method returns a subtask. So I want that to be stored into a variable. So let's call it task 1, and the other one
not really solving the naming things problem there?
No, not really. For the demo, it's okay.
For the demo,
Yeah.
To save
I
some
wouldn't
time.
do that
Normally,
in a normal
you would give
application.
them a meaningful name, right?
Yes.
Right?
Exactly. And giving a meaningful name, as you rightly said at the beginning, is a difficult problem. You have to think about the right naming. Let's keep that aside for now. Let's focus on the structured concurrency API and let's explore it now. So the next thing is to call this join method. What the join does, it actually waits for all the subtasks to finish. So in this case, there are 2 subtasks. And when join is finished, we can be completely ensured that both these subtasks are finished.
Yep.
And when they are
then
finished,
we can combine the results.
Yes. So we can get the results from, let's say, task 1. Into task1.get, it gives us accounts. And then we can also do task2.get. I can use command completion, right? Yay.
Yes.
Use local variable. Yeah, nice. First time.
Thank you.
So we get accounts and loans information. Yeah, so this is exactly what we wanted from the structure. Now the next thing is to get the credit scores. Let's introduce this task. For that, again, I have a service already prepared. I came prepared. So we have a logger like any other service. We have REST client and we inject it with the constructor injection. And we have a method that uses the REST client to get the credit score. But again, we have 2 credit score services.
And we're okay getting a response from
either of them. Yeah, exactly.
We just need a credit score for this person. Yeah.
So we call it twice. We first get credit score 1 for this customer, and then we get credit score 2. Now, as you said, we want these 2 calls to be made concurrently. We want to make these calls at the same time and then see which one gives us the successful result. So we will again put them in a structured concurrency. Let's use STS and add our calls here. And because we want 2 tasks before, because the calls will be made concurrently, we will use scope.fork, which makes these 2 calls. And then we're going to join them. Maybe I can quickly go back to loan controller because I want to quickly check something. Maybe I forgot to mention one thing. When we call join, it throws an exception, interrupted exception. And in this case, we just want to handle it by throwing our beloved A-bank exception.
This is where we usually say you don't have these to-dos in your application, right?
Exactly. Make sure there is no to-do left.
But this is one of the downsides of having the checked exceptions is that, okay, I have to do something. Okay, fine, I'll put a to-do here.
Yeah, exactly. You just put to-do and then...
or worse, this should never happen.
Yes. At least put something, like throw something there so that it is locked somewhere and you can notice it. Yep. Yes, so, and don't leave any to-do unfinished. Get to it, finish it in a nice way. Okay, let me go back to credit score service. Again, here join throws exception, so I'm going to handle it by just throwing a bank exception. Again, exception handling could be better, but for our demo,
for demo purposes, we'll keep it simple. Yeah.
Okay, so we use the same pattern as we used in loan controller. It's going to do exactly the same thing. So we first use structured task scope.open, then we fork subtasks, we join them. So the way this will work is it will also create these subtasks and it will wait for all of them to be finished.
Right. And in this case, we wanted to say we're okay with finishing one of them and then the rest can be cancelled.
Exactly. So how do you do that? Well, we can pass a joiner to the open method. And there are a bunch of joiners already available to us.
Yep.
We're going to use one of them, which is any successful or throw. What this joiner does is it ensures that when you call this join method, there is only one successful response. So when
as soon as one of them is successful, it will continue and
cancel the other ones.
Cancelled, yes.
And because we have only one successful task completed, join also returns the result of that task. So we can get it over here. Okay, I'm going to use .var, and that is going to give me my score. And we can also define the type of this response in here. So we say credit score. So we know that the return type of this join is going to be credit score. We have the credit score, and I'm simply going to return that score from here.
Right.
And I can remove this. Yeah. So this way we have now ensured that we use structured task scope with a joiner that has a specific join mechanism. And in this case, it only waits for one of them to be successful. The moment it is successful, it is done and then returns that result. And that is exactly what we want for our credit score. Okay, so credit score service is implemented. Let me go back to loan controller and introduce that here.
Yeah, now we need to wire that into the process so that we get the credit score and then calculate the offer.
Yes. So what we'll do is scope.fork and fork our third task, which is going to be credit score service dot credit score for the current customer. And I think there's a shortcut to get the variable. Yes, task 3. It also knows the, wow, it's brilliant. Okay, so we'll get the task 3.get, which is going to be, let's see if it knows. Yes, it knows. Okay, so it knows that it's credit score. Yeah, we have everything now. So the next thing is, if you look at the picture here, we implemented everything. The only part that is remaining is to calculate the offer.
Based on the information that we
already have. Yes. Yeah. So, and it is a service, or it is a method available in loan service.
Yeah, as we've seen.
Yeah. So we saw earlier. So this is going to be our current customer, and we pass everything: accounts, loans, credit score, amount, which is available in the request, and the purpose of the loan. So we have everything. Let me make it slightly more readable. And then this gives us an offer, and I'm simply going to return that offer here. So we have everything implemented according to this task structure, and this should work. We have written a lot of code. Now let's see. Let's cross our fingers. Let's restart the ABank application. And when that has done, let me go to my terminal and send a request. So let me clear some stuff up. And I think I have something prepared. Yes, so I can send this request to loan application, and this should go through the whole application to give me loan application. So let's quickly send that and go to the log to check what is happening here. So here we get the request for customer, we get the customer details, we send the request for credit score, accounts, for both the credit scores, we get to get the loans information. We have the credit score 1, which is done, and therefore the second one is cancelled. And then we have accounts info received, loans info, then we send the calculate offer service call, and then once that is done, we should have our offer, and we should be able to see that on the console. We see it here.
Perfect.
So everything that we implemented has happened.
Yes.
Let me show you a couple of things. So let me go to the log, and then we see here that all of these are virtual threads. So basically the structured task scope, what it does is all the tasks that we are forking, it creates virtual thread for each of those and executes tasks within that virtual thread. Also, what else? Yeah, we mentioned a few things, right? When we were discussing about when we were discussing about structured concurrency, that it has certain benefits, which are, let me quickly go back to that slide, about short circuiting, cancellation propagation, clarity, and observability. Yeah, let's talk about them one by one. Or rather the two of them first, short circuiting and cancellation propagation. Yeah. Now this happens, let's say we have this 3 subtasks and we want response from all of them. When one has issues or one fails, the others are cancelled immediately.
Yeah.
Also cancellation propagation. Let's check this by simulating an error scenario in our application. For that, I'm going to head over to services app. And what I will do is I will introduce an error. So we have account service.
We'll have one of the methods throw an exception and then see what happens.
Yes, exactly. And see if it actually works the way we expect. Even if it fails,
normally
it should fail
you'd write a test for this, right?
Exactly.
You'd write a test for this, right?
You should write tests for all these error scenarios.
Yes.
There are quite some of them, so I would encourage that people write tests for all of these.
I hope people test our code, but you know.
So let's say we are throwing a runtime exception here called error. And let me now restart the services app. So now accounts service is going to fail. Let's see here quickly what we have in our application. So when account service fails, it should also trigger cancellation of loans and credit score service, unless they have already finished.
Yes.
But it should trigger the cancellation of these tasks.
Because they no longer need to continue because we're not going to get all of the information to finish the offer anyway.
Exactly. So let's see, that is how it works. So we have restarted this application. Let me now send the same request again. And let's check what is happening in the logs. So we go here. We go to the bank application. Oh, there is an error, which is what we expect. It also says accounts. So basically,
I
the
panicked
account
for a
service
second there, even though we expected the error.
Exactly.
It's never good to see an error.
Yeah, it's actually, I think, an immediate response of any developer. Whenever they see a stack trace, the first thing is, okay, skip a heartbeat and then start solving
this was expected. Yeah. Okay.
So we see that account service has failed. That is what we expected. But we also see that it starts these services, but there is nothing logged afterwards. So what that means is it actually canceled the other tasks.
Right, because we don't see them continuing or finishing.
Yes, so that is the short-circuiting. But credit score service is also cancelled, which translates or propagates that cancellation to the child task. So you also see that cancellation propagation happening here. Other benefit that we discussed. So let me quickly now, what do you say? Let's say what we see on the console. We see the internal server error. So we get an error back, which is again what we expected. And this error could be a bit more nicer, but for our demo,
hopefully in your front end, you would be like, oops, something or other.
Yes, and give some
service temporarily unavailable or whatever.
Yeah, yes. Okay, we see this error here. Let me quickly go back and put our working application, because we need that for remainder of the thing. So let me quickly start our services application again. Okay, so that is running. And what we also want to show is clarity, because that's also another benefit that we discussed. So let me go to loan controller and show how it looks here. So if you see, this code reflects the structure of the tasks.
It reflects the logic of what we are trying to do.
Exactly. So we have a main flow where we task these three, where we create these three subtasks, and that is what we see here. We have structured task scope, which creates these subtasks, and further we also create subtasks for within this credit score service. But all of that is visible in the code. That brings in clarity. I actually have the same logic implemented by using completable future in another instance of IntelliJ, which is here. This method is called apply for loan. It's exactly the same thing. The only thing is it uses completable future. Yeah. And the thing with completable future is that once you use it, you see it everywhere in your application, because all your method signatures are now using completable future, returning completable futures.
Right. And it doesn't even fit one screen.
Yeah, so I have to scroll down to show what's happening.
You're using context.
Yes, and it uses callbacks, which is something you would try to avoid. Yes, exactly. You don't want to go towards callback hell. So you try to avoid callbacks as much as possible to make it more readable.
Right. So whoever has this type of code can go to using structured concurrency.
For sure.
Or at least try it out. It's still in preview. You might not want to use it in production just yet.
Yeah, I mean,
it might still change.
Yes, so preview features in general, they are well tested and can be used in production, but they can change. So API can change, even features can be rolled back. So as long as you are able to.
Occasionally they are yanked, yes.
Yeah. Rarely that happens.
in string templates, but.
For example. Yeah. So it can happen as long as you are ready for it. You have the bandwidth to basically make changes as the API changes.
Everybody has plenty of time to maintain applications, right?
So but if you have time, use it. For your demo applications, definitely go ahead and use all the latest and greatest features.
Try it out,
Yeah. So if you have this kind of structure, use structured concurrency so it becomes more readable. Another thing is with completable future, debugging is quite difficult. And talking about debugging, let's move on to the next feature, which is observability. And for that, I'm going to use debugger from IntelliJ.
Yay.
This is the feature that you showed me. So I'm going to quickly show how that works. So I will go now to credit score service, and I'm going to put a breakpoint here.
Yeah.
And I'm going to start the ABank application in debug mode. So when I send the request, I can see what is happening in the application. So I will go to a terminal and send this request, and it will open debug view. Yes, so we are in debugger. And what we see here is that I can get a thread dump.
Yes.
And the thread dump view that is available in IntelliJ shows me that there is a Tomcat handler 0, and that is waiting for something because it has created a structured task scope. So yes. Tomcat handler 0, as we discussed earlier, is a virtual thread. We can also see that here. Yeah, it is a virtual thread.
Yep.
And it is the one that is processing our request.
Right.
It has created this task scope, and that scope has now 3 virtual threads. And it is also waiting for all of them to finish because we are now waiting at the debugger moment. And one of those virtual threads also has a scope created within it, and that has 2 virtual threads that are waiting. So we see that structure of the virtual threads right. here in this debugger.
So
here
it's the what was it? The accounts, the loans, and the credit score that is split into
2 subtasks.
So we can see the structure also in the debugger.
In the debugger, in the thread dump. And in fact, structure of the task, structure of the virtual threads. So this is in the IntelliJ thread dump view, but if you get actual thread dump, that structure is also visible in that file.
Yep. So
I'm going to just continue this request and start the event application normally, not in debug, or I can also just remove that breakpoint. But anyways,
either works, yeah.
Either works. So we have now discussed all the benefits of structured concurrency. Let's move on to the third feature, scope values. So basically, we looked at virtual threads, and then we looked at structured concurrency, which is basically something which is available to us because we have virtual threads as a feature. Now we're going to talk about scoped values, which is, I'll say, a better alternative to ThreadLocals.
Yes.
So let's discuss ThreadLocals briefly,
yes.
not spend too much time, although they are very useful features. Yeah. So with ThreadLocal, if you create a variable of type ThreadLocal, yeah. You have copy of that object for every thread.
Yeah, which means that it's memory intensive because you have to copy it.
Yeah. So exactly. I mean, first of all, it has its own benefits because if you want something to have different value for every thread, it could be like for every request, you create a new thread and you want it to have that value, then it is useful there.
Yes, if you're propagating it to child threads,
then it's a problem.
Not.
Yeah.
Or it could be a problem because they're mutable.
Yeah. So you are using a lot of memory. So, but let's first look at what is it good for. ThreadLocal useful for. It is useful for storing requests or such specific data because for every request you create a new thread, then you can use it to store that. Can be useful for caching. You can hold a cache for a particular thread. Observability, like for example, storing correlation ID, especially if you are working in microservices architecture. And ThreadLocals are not going anywhere. Virtual threads do support ThreadLocals the way platform threads did. So if you have virtual thread, you can also have a ThreadLocal for that virtual thread, and it would be a local object to that virtual thread.
Yes. So, and also if you're using Spring uses ThreadLocal under the hood, so that also means that you're using ThreadLocal.
Yes, so if you think you're not using virtual, if you're not using ThreadLocals, if you're using Spring, then yes, you are using ThreadLocals. So also ThreadLocals have certain issues like unconstrained mutability. Mutability is already a problem. They also say that mutability is the root of all evil. And with ThreadLocals, the mutability is unconstrained. There is no constraint when you can change the value in ThreadLocal, and when you cannot, can get you into some trouble.
Yep.
Also, unbounded lifetime. Yeah, there is a method called remove.
Yes,
on
if
ThreadLocal.
You forget to call it.
Yes, exactly. Then
it doesn't get removed.
Yes, the object stays with the thread for longer than you expect, and
that
surprising things can happen.
Could even lead to security issues if you have security stuff on that ThreadLocal.
Yeah. So there's also a good use of ThreadLocal. So it is used to hold, let's say, privileges or roles for a logged in user because you have session for a particular thread, and you can then easily use ThreadLocal to store that. But if you don't remove that ThreadLocal, it stays with that thread. And if you put thread in the pool, the next time somebody logs in, they have the context of an already logged in user. It's a big security issue. Can be a problem. Expensive inheritance?
Don't do that. Yeah.
Exactly. Don't do that. Expensive inheritance, like you mentioned earlier, it gets copied to multiple threads, and it's an especially actually, ThreadLocals by default are not inheritable. But if you use inheritable ThreadLocal, then they get copied to the child threads. And if you are using virtual threads, where you create thousands or millions of threads, then you're going to create thousands of objects of that ThreadLocal without you knowing. Yep. And that means it takes a lot of memory, which is not something that you desire. But we have good news, which is scope values, because they are solving problems with ThreadLocal.
Remind me, they are final in Java 25, right?
Yes, they are already final. So we can use virtual threads. We can use scope value API because it's final. Structured concurrency. If you're okay with preview, you can also use it. So scope values are immutable. So the immutability problem is not there. All allowed threads use the same copy, so that expensive inheritance is not there, and they are inherited through structured task scope to the child virtual threads. We will see that in the demo. Yep. And they are bounded by scope, so the unbounded lifetime problem is not there. For example, what we see here, it's just a use of scope value API. We create a new instance, and that we set the scope value to a certain value, and it is only available within the scope.
And it goes out of scope, so we don't have to manually clean it up after.
Yes, exactly. So you define a scope, and that value of the scope value is available within that scope, but you can also override the value within that scope. So then so you can have a nested scope with a different value, and then that value is available only within that scope. So we can play around with the scope value API and see how it works. But you don't have to again manually clean it up. It would unset the value after that scope is done.
Right.
Okay. So
how do we use that in our application?
Exactly. So what we're gonna do before we actually use it, we are going to look at we're going to add a new feature to our application. And then we will see how scope values help with implementing that feature. For that, I'm going to do a little bit of housekeeping. Just gonna clean some stuff up. I'm gonna stash my changes, and I'm going to clean some changes that I made, and I'm going to switch to. So I have some tags that I switched to, so that my application is in that.
Is in the right state for this demo?
Yes,
yep.
Exactly.
Okay.
And IntelliJ helps with remembering these flags as well, which is good.
We have some completion in the terminal.
Yes,
We're
exactly.
working on improving that as well.
Yeah. So, okay, what we have here, let me quickly go to loan controller, and because we have made some changes, I think I closed it, so I will open it. Loan controller. Yeah, so what we have here, we see this method apply for loan. It has changed a bit. So what we have done is we have moved all the part that was using structured task scope into its own method called get customer info, which returns customer info, which consists of accounts, loans, and credit score.
Right. So all that before?
Yes, exactly. So we return the customer info, and then we use it here to then do the calculate offer. So there is nothing that has changed. Logically, it is the same application. So I'm just going to quickly restart a bank application and then do a quick call to the loan application endpoint to see that it is actually still working the same way that we want, just to ensure that
it's always good to check that things are working before you make more changes, because otherwise if you break it, now you have to figure out whether you broke it or it was already broken, and that's annoying. Ask me how I know.
Story of my life.
I know, been there, done that. Yeah.
No, I see everything, like all the calls have been made, and we also see that we get a loan application back. So everything is working fine. Nothing is affecting wrongly our application. So the next thing that we want to do is, I want to actually make, so we can trace all these logs. We can trace what is happening with the request by looking at the log. This is fine as long as I'm making one request. But what if I'm making 3 concurrent requests? Let's say I make 1, 2, and 3. Now, if I go to my log, I have no clue what is happening in each request.
Which is which?
Exactly, which is which. I have no clue. If something throws an exception here, I don't know which request threw an exception.
Right.
So how do we solve this? We can introduce request ID and give an ID to each request, and then log that with every log statement, and then we will see that which request failed. Okay, let's go ahead and
preferably propagate that to all of the services that would then also use that ID, etc.
Yeah. We have to
etc.
We have to make the entire application aware of that request ID and then log it everywhere we have log statements. So a simplest way would be to use random UUID, and let's call it request ID. Well, it knows, and I'm going to propagate that to all the methods. So let's say get customer, add it as a second parameter, and then log it here and here. Request ID, which is fine. This would work. But the problem is I have to do that for almost whole of my application. I have to change almost all the signatures, add this request ID, and then log it everywhere. And tomorrow the product manager can come and say, oh, now we want some other metadata. We want this and that to be known in our application. And then I might have to add those parameters to my method. So that is a problem. How do we solve it? Well, luckily we are using thread per request. So every time we get a new request, we create a new virtual thread and then we handle the request there. So we could use ThreadLocal. So we can have a ThreadLocal object.
ThreadLocal has all of the downsides.
The downsides, yeah,
so
exactly.
now we can use scope values instead.
Exactly. Every time you think about ThreadLocal, think scope values.
Yeah.
Exactly. So use scope values instead of ThreadLocals. Let's add a new scoped value. For that, I'm going to quickly go to domain and then create a new Java class called request context. And request context will hold my scope value. Let's make it public static final scoped value of type UUID called request ID, and let's initialize it. So there is a method called new instance which creates a new instance of scoped value, and then let's use it in our loan controller. So here, so this is how the scoped value API looks. So we do scope value dot where. I mean, there are a bunch of methods, but this is the simplest way to use it. Scoped value dot where, and then we can set the value. So in this case, it's going to be request context dot request ID. Let me do a static import to set it to request ID, and then we call and then pass a lambda. So within these curly brackets, the scope value is available to us.
Right. That's the scope for the
that scope value.
Yep.
Yeah. So I'm going to move all of.
Sometimes, this is where naming comes in handy.
Exactly.
Yeah.
Exactly.
Sorry.
Naming is difficult.
Yeah.
Yes, naming is difficult, but when it is done right,
it's actually helpful.
Is the most helpful thing that you can have for any API user.
And I think I read some research that having good names will still also help if you're using agents instead of humans to write and understand your code.
I can totally see that. So let's move all of this code within our scope and also format it better. Okay, so we have now a request ID as a scoped value and it is available to us here. So we don't need to pass it to any method. So let's remove it. Okay, how do we get request value? We get it from request context. Request context dot request ID dot get request ID. There we go. So we have request ID and we are logging it everywhere.
But we no longer have to pass it around because we can get it from the context.
Yeah. So this lambda returns an offer, which we can also return from here. And then now let's go ahead and implement that for the other services, including account service first. I would like to go in that order, like account service, loan, and
same
service.
order we had,
Exactly. The way we want them to be called, the way we want have implemented, I would change.
So the structure in your mind. Then?
Yeah, there is some kind of structure in the brain. It's maybe use the structured concurrency underneath. Okay, so we want to get the request context dot request ID here, and I'm gonna copy this so I can use it later on and log it here and here. This is also a nice handy feature to type at multiple locations. Let's go to in this case it's going to be loan service, and in loan service we actually have two methods, so we'll do it twice and log it here, 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 and here. Okay, yep, and then let's do it the last time for credit score service. We don't have to pass it, but we actually have it available in the scope, so we can take it from the scope. So we log it here and here. This is the last place to log, and then we are done. So let's restart our application. Oops.
And we should be able to see for our multiple requests which
which log statement corresponds to which request, so we can trace the whole request within our application. Okay, so let me...
Then we can put that stuff in dashboards and make our whole landscape more observable.
And put some graphs and flashy...
things that managers like, yeah.
Yes, exactly. Okay, so we make multiple requests one by one, and then let's go to the log, and let's see what is happening here. We see some UUIDs. So this is the first UID, which is... So all these requests are for... all these logs are for that request. And that is now calculating offer. The second one is calculation offer is done, and the third one also done. So basically, all the three requests we can track them or trace them how they are being fulfilled by our application. Something goes wrong, we know which request failed. So we have basically fulfilled our feature. Let's quickly go back to the console and see that all the requests are fulfilled. So 3, 1, and 2. That's the thing with concurrency. You never know in which order they come. Yeah, so that is done. Let me also, tell you something about the feature itself. So what we did was we set the scope value here in the parent virtual thread, the one that actually creates these child virtual threads. But we use the scope value in the child virtual threads within these methods. How is it possible? It is possible because Structured Concurrency API inherits the scope values from parent threads to the child threads and even to their child threads. So that is basically scoped values and Structured Concurrency API working together.
Yeah.
That was the last demo, I think.
I'm sure there's a good joke about weaving and Loom in there somehow about how these features work well together. But yes, you have to come up with your jokes in the comments.
Yeah, and there are some jokes from Jose Poma in his talks as well about things. He was saying Project Loom is looming around, and now it's blooming. And I think he's
I love a good pun. Also, give me your best puns in the comments, please, and thank you.
So that was about scope values. Let's quickly summarize what we discussed. So we started with virtual threads, and virtual threads enable high scalability without compromising on readability. So that is the advantage of using virtual threads. The Structured Concurrency API, it is built with virtual threads as foundation, and it provides structural approach to modeling concurrent tasks. Scoped values, they are better alternative to ThreadLocal, and as we saw earlier, how it works together with Structured Concurrency. So Structured Task Scope API enables the inheritance of scoped values. So that's how these APIs, these different features of Project Loom, they work together to enable us to write readable concurrent code.
Yes.
So that's the advantage here.
So making concurrency slightly less daunting.
Exactly.
Which is a good thing.
Yeah. I mean, writing concurrent applications is already painful.
Yep.
So if with these features we can make it less painful, it's always better.
Cool. Thank you so much for your explanation and demos and for being here and taking the time to basically demo this to us.
Well, thank you for having me here, and I hope this gives you some information, some direction where you can explore on things more.
Yep.
Thank you.
So let us know what you think about the demo and how you like Structured Concurrency and Friends in the comments. And thanks for watching. We'll see you in the next episode.